All right, I promised that we would do a more complicated determinant problem, and here one is. You can see that's a lot bigger, so the simple crisscross method we used before doesn't quite transfer over, but we're going to use the same logic and get the same place. You know that it's asking for a determinant and not just stating the matrix, because instead of having the square brackets around it, it's got these like parallel lines that imply like kind of like the absolute value symbol does. So same thing, in the same way that like an absolute value is inviting us to look for a number, this is inviting us to look for a single value. The process is almost the same. When we tried to find our determinant last time, we took this diagonal line, multiplied it together, and so we're going to do the same thing. 1 times negative 4 times 5. So 1, negative 4, 5. But that's not our only diagonal line that points that same direction. So we're going to take this next one, 2 and 1, and then like if you imagine this wrapping around the other side, it would also hit this guy. Like it would wrap and get that guy too. So 2, 1, and 1. That means 2, 1, and 1. And then, again, like you'll see, we still haven't gotten all of them. You'll take this 3, that 0, and that 3. 3 times 0 times 3. And now we have all of our values that are slanting this way. We're going to go back in and do the other direction, the crisscrossing that go back the way we came. So I'll start up here at the 3, and I'm going to crisscross diagonally that way to the negative 4, and then keep going to the 1. So this is going to be like, these are all the ones that were the first half. Now it's minus all of these things. So the first one is 3 times negative 4 times 1. And the next one is 2 times 0 times 5, which I want to do in my head, but I'm not going to for the sake of showing my work. So 2 times 0 times 5. Cool. And then the very last one that slants that same direction, we take the 1, and it goes down to this one, and it goes to that 3. So 1, 1, and 3. Once you have that all laid out, despite the fact that it's a mess, it is a disaster, we can figure out the stuff from here with simple arithmetic. So 1 times negative 4 times 5 is negative 20. 2 times 1 times 1 is 2. 3 times 0 times 3 is 0. And then we minus the other 3 terms. The first term was 3 times negative 4 is negative 12. 2 times 0 times 5 is 0, who cares? And then 1 times 1 times 3 is 3. Okay, I'm going to resolve these brackets on the inside first before I add them out there, because why not? Negative 12 plus 3 is going to be a negative 9 in the brackets, minus that. It's weird that I'm using brackets while we're doing a matrix problem. You understand, I hope, that these brackets are not a matrix. They're just the normal mathematical brackets. Sorry. Negative 20 plus 2 is going to give me negative 18. So I have negative 18 minus negative 9. Minus a negative is the same as plus. So negative 18 plus a 9 is going to be negative 9 is my determinant for that whole ridiculous matrix. The key of this, and the thing that you may need to go back and rewatch, is that when you are finding the determinant of a matrix, you take all the things that slant down to the right and subtract from that all the things that slant down to the left in the same rows that they normally are.